Welcome to ARC's webinar. My name is Constanze Schmitz and I'm an analyst for the ARC Europe, focusing on process automation. Today, I'm here with our senior consultant, Thomas Menze, to talk about the opportunities of hydrogen and how to benefit from them. We all know that hydrogen is versatile. Today's technologies already enable hydrogen to produce, store, move, and use energy in different ways. Currently, a wide variety of fuels are able to produce hydrogen, including renewables, nuclear, natural gas, coal, and oil. It can be transported as a gas by pipeline or in liquid form by ships, much like liquefied natural gas. It can be transformed into electricity and methane to power homes and feed industries, or into fuels for cars, trucks, ships, and planes. Hydrogen can help tackle various critical energy challenges. It offers ways to decarbonize a range of sectors, including long-haul transport, chemicals, iron and steel, where it is proving difficult to meaningfully reduce emissions until now. It can also help improve air quality and strengthen energy security, as despite very ambitious international climate goals, global energy-related CO2 emission and outdoor air pollution remains a pressing problem. Thomas will now take us deeper into the topic. Take it away.
Okay, Constanze, thank you very much for this warm welcome. And you said nearly everything so far. But again, let's focus on the hydrogen discussion from three different viewpoints. So why is the topic of hydrogen discussed so often right now? What are the typical characteristics of hydrogen? And how will the hydrogen initiative transform the automation market? That is maybe the most interesting fact for some of the control equipment suppliers, and we are going to cover this later. So let's start at the beginning. Why is hydrogen currently part of nearly every discussion? And let's start with a photo I took from Shell in Canada. And you see the two arrows here. The yellow one targets in the ground and the red one targets in the sky. So it is all regarding global warming and carbon capturing. So Shell said already they have a solution for the carbon capturing, but from my point of view, this is only a temporary solution. So we need a more sustainable solution. And that is exactly something where green hydrogen comes on the table. So hydrogen is not a new fuel for the industry. So we already use large quantities in some industrial areas. And the challenge today is really how can we spread the use of hydrogen to the overall economy, and how do we get it more environment friendly? Environment friendly means how we are going to produce more environment friendly hydrogen gas. And the future of the global hydrogen infrastructure may look like this. So what we see here from the left to the right, in the top, we have, let's say, first of all, the power source. So we need energy to generate hydrogen, because hydrogen on its own is not present on Earth. So we have to separate it. Then, of course, the hydrogen production process, because we have different options here. Then we need to transport and store hydrogen. And last but not least, we have really use cases where we are going to use hydrogen in the industry, hydrogen in private households or smart buildings, and of course in transportation. So in this value chain, you need a lot of sensors and control equipment. For example, in the hydrogen production area here, we need flow and purity measurement. Later on in the transportation and storage application, we need valves, we need pressure sensors, and of course temperature sensors. And at the end, we need flow measurement and purity again to really deliver the final hydrogen to the use cases. And the good or bad news is only one, let's say, area of the use cases. So only the part for the mobility, this part here right now, is standardized. So we have here an ISO standard for the dispenser application. All the rest is more or less not standardized, and we have to following here good practices. And differentiation is made between the areas of production, transportation, and storages. So we have to follow really the hydrogen gas characteristic. And in such global hydrogen infrastructure, there's an increased demand for sensors, valve, and controls. However, these sensors or these control equipment should be designed to meet the special requirements of the hydrogen infrastructure. Constanze?
That's when I have to unmute myself.
Yes. Das müssen wir schneiden.
Es tut mir leid, ich habe ein anderes Problem. Ich habe jetzt als Frage nämlich das über den grünen und blauen Hydrogen.
Ja, genau. I'm confused. Hydrogen production is very powerful.
Aber du hast das Bild noch nicht gezeigt.
Ja, das würde ich auch erst zeigen.
Das müssen wir schneiden. Okay, stop.
Stop.
We heard about green and blue hydrogen. Hydrogen production seems very colorful. Can you explain this a bit more in depth?
Yes, and that is a very good observation, Constanze. So I have a summary on the following table, and you can see it here. And you're right, hydrogen is very colorful. So we have gray, blue, green, orange, and purple. So to give you a rough overview. So gray hydrogen, first one here, is normally produced from coal. Then we have the blue hydrogen that is produced via the steam methane refinery with carbon capturing. Then green one is really made by renewables. Orange is biomass, and in this summary, something is missing. This is the purple one, and that is hydrogen production made from nuclear power. But in future, for our sustainable future, really just the green hydrogen is really important, because this is the environment friendly and sustainable production process. However, clean with produce of hydrogen in global energy transition faces several challenges, because hydrogen production from low carbon energy is costly at the moment. The International Energy Agency, the IEA, analyzes that the cost of producing hydrogen from renewable electricity could fall 30% by 2030, simply as a result of declining costs of renewables and scaling up the hydrogen production overall. Second thing is fuel cells, refueling equipment, and electrolyzers can benefit from mass production. So with other words, we are using the economy of scale. In addition to that, special hydrogen safety processes are required, because, Constanze, we may discuss that later. Hydrogen gas has special characteristic, and we have to follow that. But coming really back to the latest costs and an overview, or in the following exhibit, you have an overview regarding production and cost levels. First of all this data is based here 2018, so it's not the latest, but it is the newest data I found here. So in 2018, we already produced worldwide roughly 70 megaton of hydrogen. If we are producing with the existing opportunities this hydrogen, the emission of 800 megaton carbon dioxide is really necessary, and again, keep that in mind. 70 megatons of hydrogen emitting 800 megatons of CO2. This is not really environment friendly. And the cost overview, the cost per kilogram in US dollar is here on the far right side. And there's another thing we have to keep in mind. If we are going to discuss production cost by kilogram, you should keep in mind the caloric value of hydrogen and natural gas. So hydrogen has roughly 90% caloric value of natural gas. So you have to produce a bit more hydrogen if you use that in combustion processes compared to natural gas. But you see, today or in 2018, we had here the production cost with carbon capturing, and the maximum was relative close to $3 per kilogram. And you see here the renewable part, and the minimum for the renewables, the most cost-effective production comes close to this $3 per kilogram as well. You see both sides coming closer to each other. So what we have to do is really we have to build up an infrastructure to use, let's say, more hydrogen globally. So imagine build on an existing infrastructure such as millions of kilometers of natural gas pipelines. If we could use this kind of grid, and if we are introducing clean hydrogen to replace maybe just 5% of the natural gas content, that would be a significantly boost demand for hydrogen and drive the cost down. So we have to make a clever use of this green produced hydrogen to increase the economy of scale. The time is now right to tap into the hydrogen potential to play a key role in clean, secure, and affordable energy future. We already answer now 2 of our 3 objectives from the beginning. So why is hydrogen part of so many discussions? Simply because of the environment-friendly topic. It is an environment-friendly energy source. And what is in for the automation suppliers? We said the transformation, the growth of the automation landscape, it's definitely necessary if we are globally use hydrogen. Because the number of projects around the world expanding rapidly, it concludes that it's now the time to scale up the technologies and bring down costs to allow hydrogen to become really widely used.
Thank you, Thomas. So obviously hydrogen is still in a relatively early development phase. On the one hand, there are a lot of green use cases, but at the moment, hydrogen is only used in some industry sectors and follows their normal growth rate cycles. Why should automation suppliers be especially interested, especially now? How do you see the development possibilities in the near future?
Yeah, that is a good question. And the answer to this question will at least convince even the last skeptical person, because hydrogen projects are currently being massively promoted by the governments globally. This is really a trend around the world. And why is that? This is because it helps achieving the climate goals. And on the next slide, I prepared something for you, Constanze. This is just a snapshot of different applications here. And you see applications for the use of hydrogen in heating, steel production, in mobility, trucks, and other applications in railways. And there's always this CO2, carbon dioxide abatement involved. So the world is trying to combine generating a new fuel alternative, hydrogen gas, and at the same time do something for the carbon dioxide abatement. And some examples here, I said all these hydrogen projects are now government sponsored. And if the hydrogen economy is really promoted globally, then it is something which is very interesting for the control equipment suppliers. So if the hydrogen infrastructure are built up rapidly, then new designed control equipment is needed. New designed control equipment, we said that before, because we have to follow the characteristic of hydrogen gas. Before we slip into that, let's discuss this little press sniping shots. So what we see are here really government activity from the US, from UK, and from Australia. Let's start with the US. And the next one would be something in the UK, in Europe, and Australia is trying to bring themselves into the onto the hydrogen production landscape. And again, the ROI is not a KPI for the projects here, because all these projects are government granted and all the fundings are already available. And that is a big difference. That is a big difference to other, let's say, process automation projects, because you only invest in these kind of projects if you can demonstrate the return on invest. Here with hydrogen, it's differently, because most of the fundings are available. And if we look into the timing here, and this comes from the Hydrogen Council, and I apologize because this view is quite small and a bit overloaded, but let me pick out something here. So hydrogen, the prediction is hydrogen for transport is already in pilot activity. So first projects are really up and running. Hydrogen as fuel for the industry will speed up at least in 2025. Hydrogen for building to generate heat and electrical energy is in Asia in a pilot state, and hydrogen for industrial power generation will come in 2025. So you really see there are many ongoing activities right now. So we can see the projects, we can see, let's say, the money coming from the governments, and these are really the drivers for this strong growth. And that is not the end of the story, and that is not a single opinion of ARC. If you really talk to other research companies, for example, McKinsey predicts we will have 228 large-scale hydrogen projects in 30 countries worldwide. And by the way, this statement comes from this year. 85% of these projects are in Europe, Asia, and Australia. Remember, Australia, one of the target countries for investing into the hydrogen future. And 80 billion of funding is in the planning stage. 80 billion of funding, and I would say this is quite good news for the control equipment suppliers.
But is the application of control technology significantly different just because we're dealing with hydrogen now?
Yes, you could say hydrogen is just a gas. That is in principle correct, but hydrogen has special, or in some cases, unique properties, and that must be taken into account. So this also creates new requirements and developments for the control equipment.
But our research shows that the world already uses 70 megatons of hydrogen in industrial applications. So isn't the existing automation technology already sufficiently familiar with hydrogen as a primary energy?
Not really, because I would say these kind of applications are handcrafted, because the requirements are only used in few industrial applications like refineries. If hydrogen is used as global feedstock, then the control technology needs to be upgraded according to this use case. So an upgraded means hydrogen will also play a prominent role in establishing an energy supply without fossil fuels. That has been discussed already. And again, the discussion flares up as to whether vehicles with fuel cells are better than electric cars. But anyhow, hydrogen can be definitely used for the electrical generation, and we need to power up our cars in future. And the steel and cement industry, for them, hydrogen is quite important, maybe most important, because they can run combustion processes with minimum or no carbon dioxide emission. And just recently, the German government announced its own national hydrogen strategy. So you see, the ball is really rolling, and many things happen in parallel.
Let's go to the back to the basics. We're all very hyped and interested in the hydrogen market now. From an automation point of view, what do we need to know and do to get a share of that pie? So what needs to be taken into account when dealing with hydrogen applications?
Constanze, thank you. But let me answer your question with a question. So what do you know already about hydrogen gas?
So what most people know, hydrogen on its own is non-toxic and has no smell and no color. It's very volatile. And if it enters the environment in gas form, it would mix very quickly with atmospheric air and rapidly reach its lower ignition point.
Yeah, and I agree with you. And yeah, you have obviously a quite good insight into hydrogen, but that is not the end of the story. That is the beginning of the story. So let me add a couple of points here. So hydrogen is really easy to use in industry. Don't forget, we're already using 70 megaton. And hydrogen can be provided with the usual methods of automation for industrial processes. But we have to keep in mind, as you said, it is very volatile. And some of the equipment, especially the wells, need special designs. If we store hydrogen, then we have to handle deep temperatures, if we liquefy this hydrogen, and so on and so on. The combustion of hydrogen with air in internal combustion engines or gas turbines produces only really low emission rates if the combustion process is suitably controlled. So we have to think about this kind of stuff. You already said hydrogen is very volatile, correct? If gases, hydrogen enters the environment, it mixes very quickly with atmospheric air and accordingly quickly falls below the lower ignition limit. We all remember this Zeppelin disaster where the Zeppelin explodes in the US. So we have to be careful if we have a mixture, a gas mixture of hydrogen and oxygen. Shit. So let me rephrase. The electrical automation must meet explosion protection requirements. During engineering, attention must be paid to the corresponding zone classification. Only approved electrical equipment may be used because we have to avoid to become, let's say, a dangerous mixture of hydrogen and oxygen. So we have to keep this all in mind. And as Constanze already said, the flames of hydrogen are barely visible to humans because they radiate in the ultraviolet range. So the combustion, if there's any combustion, is high. So that means the flames, they spread quite quickly. And in manufacturing processes, the atmospheric must be monitored for O2 concentrations because people or humans do not realize leakages or the presence of hydrogen. So we have to think about a proper warning concept, so with sensors. And in future, more industrial control will be necessary, but this has to be intelligent networked, because remember the hydrogen value scale. It is something which works globally together. Only in this way, it will be possible to sustain and secure the fluctuancy energy demand. This reduces the depends on conventional peak load power plants and optimize the CO2 balance. I think the time is now right, Constanze, for, let's say, a short summary, maybe one sentence and a final statement, because I'm coming back to my initial picture we have used. This was this one here. And are you convinced that the hydrogen landscape will help really to be a sustainable fuel and energy source for industry and private households?
I am convinced, but so we hope we also convinced our information suppliers that they should keep an eye on hydrogen projects and add them to their targets, because there's a lot going on.
Yes, and you are right. And I really believe that many automation suppliers have the opportunity to participate in a rapidly growing market trend and at the same time do something sustainable for the environment. And I would say this is a nice last statement for our little discussion regarding hydrogen today. So thank you, Constanze, and thank you for this very fruitful conversation.